Okay, so here's another example we're going to solve by elimination. This time we don't have fractions that show up, we have decimals. So what do you do when you have decimals? Don't be scared of decimals or fractions, but getting them to whole numbers, rearranging equations, multiplying by all the terms by a certain number to get whole numbers might be easier for you. So this is how you want to tackle this one. The decimals here, okay, in order to get whole numbers, I would have to move this decimal over 2 times to get a whole number of 35. So that means if you want to move the decimal over 2 times, what are you multiplying by? 100. Very good. So that means if we multiply everything here by 100, I'm going to get rid of all the decimals. I'm going to have whole numbers. Okay? If you multiplied by 10, you would get a whole number here, but you would have a decimal still here, wouldn't you? So that's why you want to go to 100. So I'm going to rewrite both of them here. S plus t equals 100. And then this is going to be 60s plus 35t equals 5,000. Because you have to multiply everything by 100. Okay? So there's your new system. Everything is whole numbers. All right. And I want to eliminate. Okay? So let's pick the s term. Let's pick the s term. If I wanted to eliminate the s term, which equation should I multiply something by? And what number should I multiply every term in that equation by? So I want to eliminate the s. Any ideas? The top one by 60. Okay? Everybody agree with that? Oh, negative 60 is actually correct. Yes, negative 60. So if we did by 60, then we would have positive and positive. So negative 60 is exactly right. So let's rewrite that down here. So I have negative 60s minus 60t equals negative 6,000. Okay, because this 60 is multiplied in to each term there. All right? So that's gone, that's dealt with, and now this is gone. So I'm just looking at these two equations right here. Okay? Those are the same two equations that I started with. They just look a little different. Right? They just look a little different. So you can multiply both sides of an equation by anything and not change the nature of that equation. Okay, so what do I do next? I add. Thank you. That's the one little word I was looking for. I add the two equations together. 60 plus negative 60, those are going to be gone. There's a zero term, s is eliminated, which is exactly what we want. 35 minus 60 is what? Negative 25t. Very good. And 5,000 minus 6,000, negative 1,000. Okay. Divide by negative 25. And, whoops, negative here. And what do we get? T is 40. Okay. So 40 is the value for t. Okay. And so when we get 40 for t, what do I do next? I have to plug it back into one of the original equations. And I guess what? I'm going to look at this one right here. That one seems to be the easiest, doesn't it? So let's try that over here. So s plus 40 is 100. And s is 60. So we know that works for the first equation. Does that work for the second? Let's check the second. 0.60 times 60 plus, 3.5, nope, that's, 0.35t. I got too many dots there. 0.35 and t is 40. That should equal 50. So we'll get our calculators out. And what do we have there? What is 60 times 0.6? 36. What's 40 times 0.35? No, sorry, not 0.00 anything. Should be 14. Try that again. Try that again. Okay? And that equals 50? So is it 14, right?
Yeah.
Okay, good. You might have divided something or... Yeah, okay, no problem. Okay, so these are our two answers there. See that? That's how you deal with decimals in systems of linear equations, okay? Questions?